Hello Year 13 Further Mathematicians. I'm just going to quickly go through the Further Maths Pure test, just the odd numbered questions that you sat as the baseline test. I'm trying to do this as quickly as I can. So the first question was a partial fractions question where they gave you what the answer is going to look like, which was handy, and you just have to find the values of A and B. So the first thing you should have done is rewritten the right hand side as a single fraction over the same common denominator. So you have to times the first numerator by 2x plus 5 and the second numerator by 5x minus 1. And if you did that, the denominators on the right hand side and the left hand side are identical to each other, so you can effectively forget about those and just compare the numerators. And as this is an identity, you can pick any values of x, substitute those in and generate two equations. But there are two specific values of x you should pick. The first one would be making this bracket 0, which would be minus 5 over 2. If you substituted minus 5 over 2 in, you would get 6 brackets minus 5 over 2 plus 7 is equal to, this goes to 0. So B, 5 brackets 5 times minus 5 over 2 subtract 1. And if you make B the subject, you should get negative 2. And then if you do something similar but pick a good value for x to make this bracket 0, say a fifth, you get 6 brackets a fifth plus 7 is equal to a bracket 2 times 1/5 plus 5. If you make A the subject, you should get 8. And that would be it for question 1. Question 2 is a parametric equations question. So this is just an alternative form for a curve. So they say x is cos 2t, y is sine t, and you're asked to find dy by dx in terms of t, and it needs to be a single trigonometric ratio as an answer. So dy by dx for parametric equations would be dy by dt over dx by dt. Dy by dt is cos t. Dx by dt, well, cos goes to minus sine, but because you've got a 2t, you have to use the chain rule, so that goes to minus 2 sine 2t. This is in a single trigonometric ratio. You've got a multiple on the bottom, which is an ideal. So that should be the first thing you should try and get rid of. You should know multiple identities for, no, actually just one identity for sine 2t, and that would be 2 sine t cos t. So that denominator simplifies to minus 4 sine t cos t. And there is a common factor now between the numerator and the denominator, which could be written as minus 1 over 4 sine t, but the answer they were looking for was minus a quarter cosec t. That would be a single trig ratio without the reciprocal in there. part B was kind of use your answer to find the normal at a particular point. Now the normal is a straight line, so you should follow 3 steps. First step is a point on the line, so an x coordinate and a y coordinate. And you just substitute t in to find both. So cos 2 times minus 5 pi by 6, and y is equal to sine minus 5 pi by 6. And if you did that on your calculator, you should get x is a half and y is equal to minus a half. Second thing you got to work out is the gradient, which is dy by dx. It's actually easier to substitute into this because there's no cosec button on your calculator, so minus 1 over 4 sine minus 5 pi by 6. So the tangent would have gradient a half, so that'll be gradient of the tangent, and the gradient of the normal would be the negative reciprocal, so negative 2, because a half times minus 2 is minus 1. And the third and final thing is a formula. Y minus y1 equals m x minus x1. Substitute in the y value, substitute in the gradient, substitute in the x value, which was a half. And reading this question again, it just says find an equation, so there's not a simplified equation, so you could leave your answer like this. But if you wanted it in the kind of pointless form, it'd be 4x plus 2y minus 1 is equal to 0 if we made everything integers and equal to 0. Okay, let's have a look at question 5. So question 5, we've got 3-dimensional coordinates, A, B, and C. And you're asked to show that the triangle formed when you join A, B, and C is a right-angled triangle. So there's a few ways you can do this. You could think of it in terms of the gradients of the lines AB, AC, and BC, and the properties about perpendicular lines and their gradients. Or alternatively, the one thing that definitely works for any right-angled triangle and only right-angled triangles is Pythagoras' theorem. So I'm going to work out the lengths. That's the way they're expecting you to do this. So the length AB would be minus 2 subtract minus 2 squared. So the difference in the corresponding coordinates, 0 minus 4 squared plus minus 4 subtract minus 6 squared. AC would be minus 2 subtract 3 squared plus 0 subtract 4 squared plus minus 4 subtract 4 squared. And finally BC, difference in the x value squared would be minus 2 subtract 3 squared plus 4 subtract 4 squared plus minus 6 subtract 4 squared. And then simplify these as surds. So AB goes to root 20, that's what I simplified to, but that'll do. AC goes to root 105, and BC goes to root 125. So right-angled if satisfies Pythagoras' theorem, which would be BC squared equals AB squared plus AC squared. And if you substitute that in, the left hand side is equal to BC squared is 125. Right hand side equals 20 plus 105, which is 125. Left hand side equals right hand side. Therefore, right angled, something along those lines. I might just actually quote Pythagoras' theorem as well. There we go. And that would be it. Now, let's move on to question 7. It's a proof question. One of the ones which, there were 3 or 4 different proof questions which could come up. And if you can't recreate this proof, you just have to memorize it. So, infinitely many primes, and you have to do this by contradiction. So the only good first step is to assume there's a finite number of primes. Now, in words, this doesn't really help at all, so you're always trying to rewrite this sentence in terms of mathematical symbols. So if there's a finite number of primes, I could list them and there would be an end point to this list. So I call it first prime, second prime, third prime, P1, P2, P3, up to this finite number of primes, Pn, for example. So they are the list of primes. And now my attempt is just to use logical mathematical steps until I end up with a contradiction. And the contradiction I'm looking for is a prime number which doesn't belong on this list. Because this should be the entire list, but if I can find a number which is not on this list, that means my original assumption was incorrect, therefore the original statement is correct. So, best way to do this is considering the product of every single prime number, so just times them together. Now that number would be divisible by every single prime, because P1 goes into it, P2 goes into it, P3 goes into it, so on. Pn goes into it. But if you just add 1, when you divide this by any of the primes, which I'll just call Pi for I between 1 and n, the remainder is 0. Now if that's true, that none of the primes go into this number I've created, that number by definition has to be prime. So when you divide this by any of the primes Pi from 1 to n, the remainder is 0, and as P1 times P2 times P3 ... up to Pn plus 1 is not on the original list, it must be prime itself. I just got this logic the wrong way around. So when divide this by any of the primes Pi, the remainder is 0, which means P1, P2, P3 ... Pn is prime. P1, P2 ... Pn plus 1 is prime. And as P1, P2, P3, dot, 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 Pn plus 1 is not on the original list, this is a contradiction. That is better. This is a contradiction. And just finish off with the conclusion. Therefore, there are infinite primes. Perfect. So let's keep going. Question 9. So you've got sequences in series question. So you're asked to just bring up the question briefly. At the beginning of each month, Kate places £100 in a bank account to save for a family holiday. Each subsequent month, she increases her payments by 5%. Assuming the bank account does not pay interest, find the amount of money in the account after 9 months. So you have to decide whether this is arithmetic or geometric. Actually, I forgot to put my end of proof there. Arithmetic or geometric, and it is geometric with a common ratio of 1.05. All of these formulas are given to you in the formula booklet, but you want the total amount after 9 months, so that's a sum, so S9, which would be a r to the n minus 1 over r minus 1, which is £100, 1.05 to the power of 9, subtract 1, over 1.05, subtract 1. Please don't work out the 9 months individually and then add them up. Not ideal if you do it that way. And if you type that into your calculator, you get £1,102.66. So that's an easy part A. Part B is to show that. So on month N is the first month that she will exceed 6,000 in the account, and we're asked to show that N needs to be greater than log 4 over log 1.05. So this is a popular question using inequalities. Always a little bit harder when you've got the geometric sequences. So we want Sn to be bigger than 6,000, which means a r to the n minus 1 over r minus 1 needs to be bigger than 6,000, and a was 100, r was 1.05, and that needs to be bigger than 6,000. Now if you start to make the index form the subject, for example, you could divide by 100, chop those two zeros off, and then times by that denominator, so 60 times by 1.05 subtract 1, which I don't know why I'm doing that in the calculator, which is 3, to give you 1.05 to the power of n is greater than 4. Now normally you would you might use log base 1.05, but looking ahead at the show that it looks like they've insisted on log base 10, so I'm just going to apply logs to both sides. So log base 10 of 1.05 to the power of n is greater than log base 10 of 4. That allows me to bring the n down in front, and then I get the answer, which is n is... Now I'm just going to check to see what log base 10 of 1.05 is, because if it was a negative number, then I'd have to switch the direction of the inequality, but it's positive, so still a greater than. That's always a good check to do. If you get log, and you have to divide by it for an inequality, sometimes unknown if it's positive or negative unless you think about it. This one was positive, so I didn't have to change anything, but that would be it. Part C, probably the easier part. So this time they say Maggie begins saving at the same time as Kath. She initially places £50 into the same account and plans to increase her payments by a constant amount each month. In other words, arithmetic sequence or series. Given that she would like to reach a total of £6,000 in 29 months, by how much should Maggie increase her payments each month? So it's like a reverse kind of question. They've given you the amount, they haven't given you the common difference. So we would like to work it out. So it's, in other words, S29 is equal to 6,000. And if we work from that, we should be fine. So for arithmetic, new formula now, we have n over 2, 2a plus n minus 1d is equal to 6,000. N is 29. A is she's initially investing £50. 28d is equal to 6,000. And if you kind of times or divide by this fraction and then make d the subject, you will get, eventually on your calculator, d is equal to £11.21. So that would be a minimum amount of increase each month in order to get to the 6,000 mark. Right, let's keep going. Question 11 is a trig identity, and then using that trig identity to solve a trig equation. So you should pick on the left hand side. Let's think about different options we've got. We've got 3 different trig ratios, and we need to end up with one of them. There's no squareds in there, so I can't really use any of the formulas containing squares. So I might have to just use the identity for tan and maybe go from there. So let's try that. So sin x over cos x. Got a feeling, even though sec x is in the answer, I think because sec x is 1 over cos, that's going to be useful because the denominators on the top will be the same. So 1 over cos x over 1 minus sin x. This is, as a single fraction on the top, sin x minus 1 over cos x divided by 1 minus sin x. And this is a popular trick now when you've got a fraction divided by not a fraction, just write it as over 1. And then that is the same as sin x subtract 1 over cos x times that denominator flipped 1 over 1 minus sin x. Now we're very close to the final answer. I just have to prove it one extra thing just in case you can't see the trick for this, and that would be effectively taking a minus out as a common factor somewhere. So that was minus 1 minus sin x over cos x times 1 over 1 minus sin x, and then they cancel and you're left with minus 1 over cos x, which is minus sec x as required. Okay, and that would be it for that one. Okay, so this next one, we have to use that identity. So first thing we're going to do is substitute it in. So in other words, minus sec x is equal to root 2, or cos x, which would be this flipped and switching the sign now, 1 over root 2 with a minus. And if you make x the subject, I always draw a sketch for this just to get the number of solutions. So it's between 0 and 2 pi. Calculator should always be in radians. Draw a very quick sketch of cos minus 1 over root 2 is down there, so you're expecting 2 answers. Your calculator will give you one of them. This is one you should know. 3 pi by 4 or 2 pi subtract 3 pi by 4 to give you 3 pi by 4 or 5 pi by 4. Okay, and that would be it for question 11. Almost there. 2 more to go. Question 13. Looks like you've got some polynomial division. So you've got a cubic divided by a linear term, and you've ended up with a quotient and a remainder. So, first good step is to use long division. You can somehow use comparing coefficients, but why not use long division? So remove the first term, you have to times by x squared, and you get x cubed plus 6x squared is what you have to subtract. Bring the next term down. Then you have to remove that by times and by 2x. So you get a 2x squared to subtract and a 12x. First column disappears, second column goes to, don't make a mistake with the negative signs, minus 21. Bring the next term down. Then you want a minus 21 to get rid of this first column. 6 times minus 21 is minus 126. Final subtraction, don't make a mistake, would be 138. Okay. So then, in other words, if I be lazy and call this f of x at the start, f of x is equal to the quotient is how many times it goes in, which was x squared plus 2x minus 21, plus the remainder over what you are dividing by, which is x plus 6. And that would be it for that one. And the final question, question 15. Definitely the hardest question so far, because you definitely got to think about this one, which is integrating sine cubed x. Now, you should know that integrating sine squared x pretty quickly. That's a very common one, integrating sine squared. It's using some double angle formulae for cos. But sine cubed is a lot harder. Okay, so in terms of immediate patterns, if you've got something to a power, you might be able to use reverse chain rule, but normally you would need not just this to a power, but also times in by its derivative as well. You're looking kind of for this pattern, f of x to the power of n times f dashed of x. But it is not that, it's just sine x times sine x times sine x, so can't use that yet. I don't like the fact that it's a power of 3, so what I would do first is try and reduce that. So I'll remind myself that that's the same as sine x times sine squared x. And then at least I can replace sine squared with 1 minus cos squared x, and then I've kind of reduced the powers a little bit. I know I've gained some causes, but at least I've reduced the powers. So I've got sine x minus sine x cos squared x. Now these are kind of two completely different integrations, so I'm going to split them up, because one of them I can definitely do immediately. Sine x you can integrate straight away. Sine would integrate to minus cos. And now sine x cos squared x fits this pattern. Something to a power and kind of its derivative as well. So if you've got to integrate this, your guess needs to be f of x to the power of n plus 1. So let me try that on the side. So I'm going to guess cos cubed x, which I'll write as cos x cubed there. Let's check to see how bad this guess is using the chain rule. Bring the power down, subtract 1 from the power, and then times by that bracket differentiated, which would be minus sine. So that's minus 3 sine x cos squared x, but I wanted just sine x cos squared x, so I need to divide my initial guess by a factor of minus 3. So this is minus, divide this answer by minus 3 cos cubed x plus c. Let's just tidy that up a little bit. Minus cos x plus a third cos cubed x plus c. And that would be it. If you have any questions or you think I made a mistake somewhere, please let me know. And that's pretty much it.